I've spent the past several videos going over division of polynomials. But now I'm going to take that next step and start thinking of that division as fractions instead. The same step as saying, 1 over 2 is equal to 0.5, and then just seeing it as 1 over 2, right? Let's do some math with just terms on the top, terms on the bottom, adding, subtracting, multiplying, and dividing them. Now, the key here is simplification. Now, for example, if we had, x squared minus 1 over x minus 1, how can we simplify that? Well, this here is a perfect square. So, on perfect squaring it, we just get x plus, what am I doing? 2? Not 2. Plus 1 times x minus 1 all over x minus 1. And we can say with certainty that these two things, we can cancel them out. Now, the reason we can do that, just an explanation, is that this is saying we're multiplying it by x minus 1, and then we're dividing it by x minus 1. Multiplying and then dividing by the same exact term is meaningless because they just undo each other. That is why we can just cancel it out. But what if it wasn't that clean, right? What if I wanted to solve for x? What if we had a rational equation? What if we had something like x squared minus 1 over x plus 3 minus 4 over x plus 1. How can I combine these two together? Now, subtraction, our first step, you should get this into your head, the first step will always be getting common denominators. Meaning that we have to multiply this whole thing, top and bottom, by x minus 1, and then, plus 1, and then multiply the whole thing, top and bottom, by this term right here, because we need the denominators to be the same. So on the top, we have x squared minus 1 times x plus 1 minus 4x plus 3 all over what we had those denominators to be. X plus 1, x plus 3. Very ugly, right? But I'm just trying to show the process, of getting it all done. So let's keep going. Keep going down the list of orders of operations. Let's try x squared minus 4x minus 21 over x plus 1 times x squared minus 1 x plus 3. Okay, now, very plain and simple. Multiplication, way easier to deal with fractions when it comes to fractions, because we can just do that and then just connect the lines. Multiplication, far easier to deal with. Now, the whole process here is just going to be simplifying. Now, x squared minus 4x minus 21, what multiplies to negative 21 as to minus 4? We could do, well, this is negative 7 and 3, has to be. So negative 7 and 3. So this up here is just x minus 7, x plus 3 times x squared minus 1 all over x plus 1 times x plus 3. And now, canceling time, x plus 3 cancels with itself. X squared minus 1, that's just going to be a perfect square. So we have one of those right here. We have the x plus 1 right here, so we can cancel that with that one. So, simplified, this whole mess became x minus 7 times x plus 1. Very ugly looking. I'm not on my game today. Simplified. All right. Now, division. If you do not remember, dividing fractions, what we do is we reciprocate this second fraction right here. So what this becomes is x plus 2 over x plus 3. So let's combine them together. On the top, we are going to have x plus 3 times x minus 2 times this right here. Remember, we are flipping them over this times our numerator. But remember, we flipped it over, so it's on the bottom now. That's why we keep it right here. Now, very nice. Let's solve. Simplify. X plus 2 and x plus 2. Nice. X plus 3. X plus 3. Nice. And so, all that, we turn this big mess into a very sweet x minus 2. Done.